Welcome to section 2.5. We're looking at piecewise defined functions. All right, and again, we're going to be graphing these. So the first one we're going to graph is the absolute value function. If you recall, f of x, which is the absolute value of x, we have the two options. It's just going to be x for the values that are greater than or equal to 0 for x, or it'll be the opposite of x for the values that are less than 0. So let's go ahead and take a look at graphing this. Easiest way that I like to do is to create a little table. And then first note which of the piecewise that I'm graphing, and then picking points in the area for each of those. So let's see. I'll go ahead and first work on the x values. So that's just going to be the line y equals x. And what points are greater than or equal to 0? Well, let's see, we can do 2, 1, and 0. Those are all greater than or equal to 0. And then, for the opposite of x, we're going to head and pick points that are less than 0. And it can go all the way super close to 0, but again, just less than 0. So I'll go ahead and pick the points -1, -2. Or actually, we could even pick -0.5, because again, it can get really close to 0, but it's not equal to 0. So -0.5, -1, -2. And again, plugging these in, when I choose 2, it's just going to be the x value. So the opposite value is going to be 2, 1, 0. And then for the opposite of x, it's going to be the opposite of these values. So +0.5, +1, +2. Let's go ahead and graph these piecewise functions. So for -x, it's going to be -0.5, half. So somewhere around here. And then, let's see, -1, 1, -2, 2. And then it's going to go on till infinity, because again, it's for all values less than. So I know this is going to graph onward to infinity. Try to make as straight as line as possible and include those arrowheads. But again, it's not equal to 0 here, so open bubble there. Let's go ahead and graph the positive version. So at 0, 0 is the point, so that's where we'll fill that one in. 1, 1. And then 2, 2. And again, this one also continues on to positive infinity. And we have our absolute value function. I'll go ahead and label these points. That was 2, 2, 1, 1, 0, 0, -0.5, half, -1, 1, and -2, 2. All right, so let's go ahead and take a look at the next one, example 2. So graph the piecewise function. Is the function continuous on its domain? So again, we have the two options. For the values less than 3, we have this line. Oops, let me change that pen. For all the x values less than 3, we have this line, 3 minus x. And then for all of the x values greater than or equal to 3, we have this other line. And again, it's good to take a moment and try and figure out which equations these are right here. So again, remembering back to our equations, this is a line, this is a line. Again, this is the line, y equals 3 minus x, and then y equals 2x minus 4, just depending on what x values we're looking at. So let's go ahead and make our table. And then let's see. So I'm going to be doing the positive values of 3 or greater are for 2x minus 4, my yellow line. And let's see what values I could pick for those. Again, I always try to pick a mixture of positive and negatives if possible. We know the boundary is at 3. So then let's do 3. How about 4 and 5? Why not? And then for the blue one, the 3 minus x. Those are for all the values less than 3, not equal to 3. So we'll go ahead and do, how about 2, 0, -1? Why not? We could pick a few more negatives if we needed to. All right, and then let's go ahead and plug those values in. So that's going to be 2 times 5 minus 4. This will be 2 times 4 minus 4. And the next one will be 2 times 3 minus 4. What will those be? So that'll be 10 minus 4, which is going to be 6. 8 minus 4, which is 4. 6 minus 4, which is 2. So we have the point If I want to make another column so we can see the points a little easier, I'll do my XY column. Again, you wouldn't have to necessarily do this one. I'll just do this so you can see it easier. This is the point 5, 6, 4, 4, 3, 2. So if I graph those, let's see. 5, 6. And I'll go ahead and I'm going to label these a little easier so I don't have to write the coordinates every time. I'll do A, B, and C. That's point A, B is 4, 4, and C is 3, 2. So if you wanted to go ahead and do the labeling instead of having to write all the coordinates out like we did up here, you could go ahead and label that. Again, just let me know what they are on the side like that. And then this continues all the way, just to 3. Again, for all the x values greater than or equal to 3, it's going to be this yellow line and arrowhead. Let's go ahead and do the next line. So 3 minus x. That'll be 3 minus 2, which is going to be 1. 3 minus 0, which is going to be 3. And 3 minus negative 1, which is going to be 4. So this point is going to be 2, 1, 0, 3, negative 1, 4. And again, I'll label these as well. Let's see, we're doing a blue line, A, B, C, D, E, F. And again, I'm able to make a good sketch on these graphs because I already know that these are both lines, so there's not going to be any curving going on in these. So again, it's good to make sure to know that they are both lines or whatever graph they are going to give before we even start picking numbers. So let's see, 2, 1 for D, 0, 3 for E, negative 1, 4 for F. And this is going to continue up until really close to 3, but it doesn't ever equal 3. So we're going to have a little open circle there. And again, we know it's continuous. It's going to be less than 3, all those values. So again, we'll do that arrowhead. Okay, so again, we've graphed the two lines with the boundaries. The blue one, again, had to be all the x values less than 3. The yellow one, again, all x values for greater than or equal to 3. So then the next thing to answer is this continuous on its domain? Well, again, it's continuous if you could put a pen on and trace over the whole graph without having to jump. But we would have to jump in order to get to the next part. So this is not continuous. So f of x is not continuous on its domain. Let's take a look at the next problem. We've bumped up to 3 different parts in our piecewise function. So again, the main thing I'm going to do first, before I start anything, look at the functions and figure out what kind of a graph they're going to give you. Remember, these are all going to be y equals, so what I have here is y equals 3, y equals negative x, and y equals x squared. What type of equations would these graph? Just ignore again the piecewise part. This is the continuous function, or the constant function, horizontal line at 3. This is just a line, y equals negative x, so it's a downward sloping line, pretty much along this point here, really rough graph. The constant function is somewhere at 3. And then we have y equals x squared. What is that? That is parabola. So that is going to graph something like this. Again, rough sketch. So I already know in my mind what all of these should look like before I even start. I may not know the exact numbers, but I know that's what they should look like, and that'll give me a great sort of head start on my problem. And then again, I'm going to go ahead, draw my table. And let's see. So for x less than or equal to negative 3, we're doing 3. So because this is the negative values, I'm actually going to put those a little lower on my table. And the boundary is at 3. So let's see, negative 3, it'll do negative 4 and negative 5. And that is going to be for y equals 3. And then let's see, the next one we're looking at in between negative 3 and 0, we have negative x. So what points could I pick there? How about negative 2, negative 1, and 0? And it's not equal to either of these. So that one is going to be y equals negative x. And then lastly, we're looking at x values equal to 0 or greater. So all of whatever ones I pick here, that's going to be for y equals x squared. So what values could I pick? Again, 0 is the one I can pick for that. How about 1 and 2? Yeah, why not? I like to get roughly about 2 points for each one. All right, so go ahead and find these values. So this is going to be 2 squared, which is 4. 1 squared, which is 1. Was this 0 with the with the x squared or with the negative x? It's with the negative x because, again, we have that equal to sign on the bottom. It's not going to be equal to this one. So it'll be 0 squared is 0. So again, that's my first point. Let me go ahead and do my x, y's. Again, you wouldn't have to do this, but I like to go ahead and do some visuals here. 2, 4, 1, 1, 0, 0. Okay, so for y equals negative x, we're looking at negative 1 equals 1. Opposite of negative 2 is 2. So that's going to be the points negative 1, 1, negative 2, 2. And now, moving on to the next ones, we're looking at the constant function. So no matter what points I pick in here, my constant function's always going to equal 3, right? It's the constant function, so it's never going to change. Okay, and again, as a reminder, these are for the line, the constant function. These ones are for my slanted line, y equals negative x. And these points are all for my parabola. So let's go ahead and plot those. I'm first going to go ahead and label them, because I don't have a lot of room on my graph, so I'm going to go ahead and do that. A, B, C, D, E, F, G, H. All right, so let's go ahead and graph these. 2, 4. So let's see, 2, 4. It's going to be point A. 1, 1, point B. And 0, 0, point C. And again, I know this is a parabola, so I know it's going to be curving upwards. Again, that's why it's really good to check out what it is before you start plotting all those points. And then, so for the next one, D and E, negative 1, 0. Oh, sorry, negative 1, 1. And negative 2, 2. So let's see, again, that's the line, and that's going to be in between the points for negative 3 and 0. So it's bound here between negative 3 and 0. So that's the farthest this graph is going to go. Boop, boop. All right, let's see what else. Lastly, for the constant function, which again is going to be for all the values less than negative 3 for x, so all these values in that direction, those are all going to be points along y equals 3. So let me go ahead and plop those down. Let's see, we have negative 3, 3. Oops, wrong pen. Negative 3, 3 for EF. That was F, yeah. G is 4, 3. And then 5, 3. So G and H. And again, the constant function, so it's just going to be a nice little horizontal line with an arrowhead. Why an arrowhead? Because again, for all values less than negative 3. All right, and there we have a piecewise function. So let's take a look at the next one for part C. Okay, again, so we have 3 different parts for my piecewise function here. And again, my goal is always, first, before I start anything, identify what kind of graphs these are going to be. The first one, y equals x plus 1, is going to be some form of a regular straight line with a y-intercept at 1, heading up. So something like that. And then again, it's going to be bounded between negative 5 and 1. So between negative 5 and 1, about there. And then my next one, we're looking at y equals x squared minus 2x minus 3. Because of that x squared, I know it's going to be some type of a parabola. It's going to be positive facing parabola because, again, it's a positive x, and it's bounded between negative 1 and 1. So I know my parabola is going to somewhere be around here, upward facing. Lastly, I have y equals the square root of x. Square root of x, I know the graph of that is something like this. It's half a parabola that's facing, opening to the side. And then that one is going to be bounded between 1 and 4. So between 1 and 4, I'm going to have some part of that graph. Again, the square root of x. So again, always good first to visualize before we go ahead and do the rest of the work. Now that we have a visual on what they're going to look like, let's go ahead and pick some points. Again, at least 2 points for each one. Make sure to label them. And again, let's see. So starting with the first one, what will I give this one? I will pick the color yellow for this one. That's between -5 and -1. We're using x plus 1. So the negative values, I'll go ahead and do, let's see, -4. I don't pick -5 because it's not actually equal to -5. -4, -3, and why not -2? And that again is for x plus 1. Next, we're looking at the parabola, bounded between -1 and 1. So because it can be equal to -1 and 1, I'll go ahead and use those actual points, -1, 0, and 1. And again, that is my parabola, x squared minus 2x minus 3. And the last one, bounded between 1 and 4, and it can be equal to 4, not equal to 1. What point should I pick for that? I can't pick 1, so I'll go ahead and do 2, 3, and how about 4 as well? And then let's see, that was blue. All right, so again, we have picked the points that are good for each of our graphs here. Let's go ahead and evaluate them. That would be the square root of 4, which is 2. Square root of 3, I can't do anything to that. That's square root of 3. Square root of 2, again, can't really simplify. Square root of 2. Let's go ahead and plot our xy points. That'll be the point 4, 2. 3 root 3, and 2 root 2. Next, we're looking at x squared minus 2x minus 3. So that's going to be 1 squared. Ooh, I didn't leave a lot of room here. Minus 2 times 1 minus 3. Which, let's see, what is that going to give me? That'll give me a -4. And then that's 0 squared minus 2 times 0 minus 3, which is going to be -3. And lastly, -1 squared. Ooh, we're running out of space here. Minus 2 times -1 minus 3, which is going to equal 0. Okay, so we have that point 1, -4, 0, -3, and -1, 0. All right, chugging along. Now we have x plus 1. So let's go ahead again, plugging those function values in. -2 plus 1, which is going to equal -1. -3 plus 1, which is going to equal -2. And -4 plus 1, -3. Again, writing out those coordinates. And I'll go ahead and label all of these. A, B, C, D, E, F, G, H, I. All right, so let's go ahead and graph each of these points. I'll go ahead and start with the x plus 1, since that's just a nice regular line. Again, we know that's going to be between -5 and 1, so all of my points are going to be somewhere between -5 and -1. All right, so between those points, we have -2, -1. That's going to be G. Then we have -3, -2. That's H. And then -4, -3, which is I. And just following that pattern, again, it's going to continue between -5 and -1. Because again, that's the bounding of my graph. How come I wouldn't put an arrowhead? Well, the reason I'm not going to put an arrowhead is, again, because my x values are bounded between -5 and -1. So those are all the values I have for this line. For the ones that weren't bounded, like above, like this one here for the green, that's not bounded, which is why we'd use the arrowhead. Okay, so now moving on to the parabola. Let's see. You could find the vertex if you wanted to. The vertex is actually at 1, 4. Let's see, so that's D. Then 0, -3. It's going to be E. And then lastly, -1, 0. So again, just curving because we have a parabola, so it should be some form of curving for the parabola. And again, that's all we're doing because our parabola is bounded by -1 and 1. So that's all the points we're going to be doing for that. Lastly, let's take a look at the square root, which was blue. Those are the points 4, 2. And that was A. And then, let's see, 3 square root of 3. I don't really know what square root of 3 is, but I know that it's less than 2. Square root of 3 is going to be approximately about 1.7. And then let's see, the square root of 2 is going to be approximately about 1.4. So again, just a wee bit above 1. So let's see, 3 root 3 is going to be about here. That's B. And then 2 root 2, it's going to be about here as well. Actually, that one would be a little higher. Boop, boop. Again, just an estimate. And then we know for these graphs that, again, it's going to be a curve. So where am I starting this from? This is going to be starting from 1. Oh, forgot to mention here. These are going to be open circles. I'm sorry, these are going to be filled in circles because, again, equal to, equal to. The next one's going to be an open circle because it's not actually equal to -1. Or +1, I'm sorry, +1. So let's go ahead and see. So it's going to be somewhere about here for +1. Open circle again, and then just a small curve. Just show that there's some small amount of curvature. And then your arrowhead. And already, that is it for that section. Again, these are just small sort of rough sketch graphs. Just include the points, include the basic idea on each of those. If they're an open circle, include the open circle. If they have arrowheads because they're continuing on, include that as well. Then again, label all of the points if you don't want to actually label these ones in the graph. It's easier usually to pick just a letter to associate with, less to write on the graph. But again, up to you on that. Alrighty, let's go ahead and move to the last part in this section. Example 3, write a formula for the piecewise defined function. Give the domain and range. Okay, so this time we're doing the exact opposite. Before we were given the formulas, and then we were asked to graph it. This time we're given the graph. So what's some things I want to note first? Well, do you notice the types of graphs we have? I see some curves and some straight lines, and then some slanted lines. The main thing that catches my eye is this curve. That's going to be a parabola. And I also know that arrowhead, so my parabola is going to be continuing on at one point. Next, I see that I have a horizontal piece, a horizontal segment there. So I'm going to be using a continuous function at 3 to graph that one. And then I have a straight line going on, a slanted line going on here that's going to continue on to infinity. So I'm probably going to use the equation, let's see. Well, the points would be at 1, 1, 2, 2, 3, 3, 4, 4. I'm going to use the equation y equals x for that one. So again, I just looked at all of them, sort of plotted the ideas in my mind there. Now let's go ahead and piece it together. So we're going to go ahead and say f of x is going to equal what? Well, the first one. Let's start with the parabola, because I'm just going to go ahead and read from left to right. You don't have to do that. All the graphs above weren't given exactly that way, but I'm going to go ahead and do that. So from negative infinity all the way up until, boop, 1, we're using this parabola. So again, from negative infinity up until 1, we're using that parabola. And that parabola is going to be, let's see, -1, 1, -2, 4. That is going to be the y equals x squared parabola. So for y equals x squared, would actually just write x squared. We're going to use x squared for what value points? Well, from negative infinity all the way up to 1 for x. So basically for x less than or equal to 1, we use the parabola. Okay, good. Got that down. Next, what's the next segment? Well, we see that little horizontal line there at y equals 3 between the points 1 and 2. So since it's between those points, we're going to go ahead and use 3 for x bounded by 1 and 2. Is it equal to either of those? Well, it's not equal to the one there, so that's an open circle, so we wouldn't write the equal to, but it is equal to the 2. So I'll go ahead and draw that little equal to sign down there. Okay, almost done. What's the next piece we're missing? We're missing that slanted line, which again I've identified as y equals x, because again, all these values are matching up as we go along. That's characteristic of y equals x. So go ahead and use x. And then what points are those for? Well, from 2 until, oh, we have that arrowhead, 2 to infinity. So for all the x values greater than, are we letting it be equal to 2? No, there's an open circle, so we're just going to be greater than 2. Alrighty, and there we go. We have created our piecewise function. Again, First things first, identify what kind of a graph it's going to be, and then you can build on that. Identify the graph, identify the intervals they're going to be in. Again, like this, for this interval, it was between 1 and 2. And then identify if it's going to be open circle, closed circle, and also the boundaries if they're going to infinity or not. Okay, last thing we got to do is the domain and range. So again, domain are my x values. So the domain of f of x, let's see, what's that going to be? Well, we have that arrowhead, and then it continues on, and there's this break between 1, but we do include the value of 1 somewhere. So it's going to keep continuing on, and then, there's another break here, but again, we still include 2 up there. And then it continues on to positive infinity. So, negative infinity to positive infinity. Even though there's those small breaks, those points are included somewhere in the graph. Next, let's go ahead and do the range. Let's see, range again are my y values, so we're looking for here. So we start at 0 for my y values, and it continues, it continues all the way up. Even though I don't use these points for this graph, I still use it here. So again, we're just making sure that our points are used somewhere along the line. So the domain, or in the range, is going to be from 0 to positive infinity, and that is it. All right, that is it for this section. If you need any review on any of the graphs and just identifying them, let me know and I can send you a worksheet on that. Other than that, please email me if you have any questions.